day after school, Larry Smith was riding down the alley on his bicycle. It was wonderful weather to be out. And, uh-oh, that in that barrel. Seems funny to throw away such a new-looking doorbell. Sure will be fine to play with, though. Kay, Larry's little sister, thinks Larry is a wonderful brother, and she is always interested in everything he does. Take that doorbell, for instance. Kay wants to know what Larry is going to do with it. Larry is going to take the doorbell down into Dad's basement workshop and see if he can make it operate. Larry has been studying science in school, and he believes he knows how to make this doorbell work. Several minutes later, Larry is hard at work trying to make the bell ring. Though the bell is connected to a dry cell, it won't ring. It's just more than Larry can figure out. So Kay is sent for help. Big Brother Bill can usually be counted on to help with such problems. Now, let's see what the trouble is here. Well, the electromagnet has a broken wire and isn't operating. Electromagnet? What's an electromagnet? Asks Larry. Well, we had better start from the beginning, answers Bill. You two get some wire and nails, and I'll get some other things. Now, this is an ordinary permanent magnet. What do you remember about magnets? Yes, Kay, a magnet attracts things of iron or steel. It attracts the needle of a compass, too. Now, do you suppose this copper wire is a magnet? Well, it won't pick up these small nails, but maybe it just isn't strong enough. Let's try it on the compass. If it is a magnet, it will make the needle move. It doesn't, so it isn't a magnet. Now let's see what happens when the wire carries an electric current. We can start the current flowing by attaching the wire to an electric dry cell. Now the compass needle moves. The electricity has given the wire magnetic force. But it still hasn't enough force to pick up the nails. Can we make it stronger? When we connected the wire to the dry cell, the electric current flowing through the wire caused the wire to have magnetic force, enough force to move the compass needle. But since the magnetic force is spread along the whole length of the wire, no part of it is strong enough to pick up the nails. Now, Larry, wind the wire into a tight coil around this pencil and see what happens. The magnet is stronger, but not yet strong enough to pick up the nails. Now let's give our magnet an iron core. We can do this by putting an iron nail inside the coil instead of the pencil. Now try it, Kay. It works. Let's see why it works. The weak magnetic force, which was spread out along the straight wire, becomes stronger as the wire is coiled, because this concentrates the force into a smaller space. The iron nail makes an easier path for the magnetic force to concentrate inside the coil, and makes the magnet stronger. Now, Kay, let's try our magnet on something heavier, like this wrench. No, it isn't strong enough. How can we make it stronger? That's right, Larry. We made it this strong by coiling wire around the nail. Why not try even more wire? It's stronger now, but still not strong enough. How can we make it still stronger, Kay? Do you have any ideas? That's good, Kay. We can get more electric current with 2 dry cells instead of 1, and this should make our magnet stronger. Yes, this time it works. More electric current has done the trick. A magnet that uses electricity to do its work, such as the one we have made, is called an electromagnet. Ours is strong enough to lift only small pieces of metal, but in junkyards and steel mills, big electromagnets are used to move heavy loads. These electromagnets are so strong because they have miles of wire in them, and they use a great deal of electric current. And do you notice how this big electromagnet not only picks up its load, but also drops it in exactly the right place? That's something a permanent magnet can't do. Do you suppose we can make our magnet drop the piece of iron when we want it to? Of course we can, by simply opening the electrical circuit. We can control our magnet simply by opening and closing the electrical circuit. That's what makes electromagnets so useful, not only for lifting things, but for a great many other purposes. For instance, can you guess what this is like? The electromagnet pulls the metal strip down and makes it strike the bell. Actually, almost the same thing happens in a real electric bell, only much faster than we can do it by hand. But to make the electromagnet in our bell work, we must have a closed circuit. If the wire is cut or broken, we have an open circuit, and the bell won't ring. That's the reason your doorbell won't work, Larry. It has a broken wire. We can close the circuit by simply twisting the broken wires together. Now your doorbell is almost as good as new. Now that we have repaired the doorbell, let's review some of our facts about electromagnets. A wire by itself has no magnetic force. But it does have magnetic force when there is an electric current flowing through it. We can concentrate this force by winding the wire into a coil, and make it stronger by giving the magnet an iron core. We can make it still stronger by using more wire, or by providing more electric current. Electromagnets work only when there is electricity flowing through them. We control them by turning the electricity on and off. Doorbells have electromagnets in them, and so do many of the other everyday things around us. The bell in your telephone rings by means of an electromagnet. And if we could look inside this electric motor, we would see electromagnets there, too. Yes, the electromagnet is one of the many wonders of electricity, one of the many ways in which we make electricity work for us. And what interesting things our friends have learned from the electromagnet in the broken doorbell and from their big brother, Bill.